This tutorial is an introduction to programming the Arduino Uno board. So let's look at the Arduino board real quick to understand the hardware that our program, which we call software, is going to control. Now, the programs that Arduino uses to program this are called sketches. And the sketch is just a text file that contains formatted syntax, and syntax is the language that the microcontroller understands. So we will be going over and creating a simple introductory sketch to get you going. But before we do that, we need to understand what these pins functions are. Now there's some power pins down here in the lower left, and on the lower right is analog pins, A0 through A5. Now analog refers to values that could potentially be infinite. They have many values. We will be using in the beginning the digital pins on the top here, pins 0 through 13. And digital means they can only have two levels on them. 0 or a 1, high or a low, on or off, 5 volts or 0 volts. So we also need to make mention that these pins, when we are going to use them, we can use them as an output or an input. Now, an input means, or an output, is from the point of view of the microcontroller on the Arduino board. If we tell Arduino in our program that this pin 13 is going to be an input, that means Arduino is going to read whatever voltages are on that pin. They are not going to do anything else to that pin. They are only going to read it. We, on the outside of the board, have to put voltages onto pin 13 if it is an input. And the other state that it could be, we can say that the pin 13 can function as an output. If pin 13 is an output, Arduino is responsible for putting voltages onto pin 13. And they'll either put a 0 volts or 5 volts on there. So with that being said, let's go into the Arduino integrated development environment. And we have a blank sketch here. Now we are going to talk about when it first starts up, you do not see an area above this void setup function. If you, with your cursor to the left of the void, if you hit enter, it opens up space above the setup function. This is where you're going to put your header information. Now comments are words and documentation that we put into the sketch that do not get translated into machine language. They are ignored. The purpose of comments is for us to document our program and to know what is going on. So the comments here, we are going to be putting in the header where we're supposed to put our name, in our period number, mine is all, and this is going to be a tutorial. And so after we do this, we have created a header. Now this is not complete. You need to look at the design challenge to figure out the commented area of the header that you need to put in. Now what we're going to do in this sketch, there are basically three areas. There is the area here above the setup function. There is code, instructions, and when I say code, I mean a set of statements and instructions, variables, control structures. that are put inside these braces. Now, we're going to, most programs are broken down into variables, statements, setup statements in the setup function, and statements in the loop function. So we are going to create a variable, and a variable is the same as a variable in math. You can think of it like a box that contains objects that we are going to use. Now, to make a variable, we use keywords, which is part of the syntax to do this. Now, the box that we're going to use to represent a pin number are whole numbers, which in programming is represented by integers. So the keyword int represents integer. When you type int, it turns color. The integrated development environment recognizes keywords and highlights them to let us know that we have typed a keyword that it recognizes. So we are going to create a box that will hold integers, and we're going to call it red LED. And then we are going to use an equal sign to assign it to the pin number 13. Now, I'm going to actually call this sorry about that, LED anode pin equals 13. And I'm going to use another variable, another box integer, LED cathode pin equal to 12. So I'm going to connect on the Arduino board. I'm going to use pins 13 and 12. Instead of the ground for my diode, I'm going to be using two digital pins to connect to my LED and control it. So I'm going to use these two variables to represent those two pins. Now, once I have these variables and they have these numbers in them, they are not doing anything yet. They only do something when we use them later. Now we're going to use them here inside this setup function. Now the setup function has comment says put your setup code here to run once. When your sketch is downloaded to the Arduino board, it runs from top to bottom. It will go line by line and execute the instructions and the statements that we have created here. Now, this here that I've highlighted is a completed statement, a completed sentence as it were in programming language. And statements end with semicolons. If you do not use a semicolon at the end of your statements, then it doesn't know that this is a completed statement. The common errors that are made is when you forget a semicolon and a bunch of statements are run together and make no sense to the computer. Now inside the setup function, what we need to do is we need to tell Arduino, so I'm going to comment here, we need to tell Arduino that we are going to use, now these forward slashes here are single line comments. They're only good for one line. And so if you want 2 lines, you need to do it again. Type forward slashes. We need to tell Arduino that we are going to use a pin and how we are going to use that pin. We do that using the pin mode function. We do that using the pin mode function. And when I talk about functions, you can recognize functions that are a set of words or letters that are ended with these braces. That's how functions look like. So the setup with the brace here, this is a function. The loop, word loop here, also has curly brace in. So the loop is a function. So we have 2 pins. So for the LED anode pin, we're going to pin mode. And a lot of functions, now functions can have arguments. Arguments is information that the function needs to work and do its thing. Some functions don't need any input. Some functions do. The pin mode function has 2 arguments. The first argument is the pin number and the pin mode, as it were. So we could have typed 13 here, but instead of using the number itself, we're going to use the variable LED anode pin, a variable in its place. So wherever I use LED anode pin, as long as it's assigned here 13, everywhere I use this variable name, it's a box with a name, so everywhere I use this box, it has the value of 13. Then we got to tell it whether we're going to use this input or output. We are going to be controlling an LED, which means we want Arduino to put voltages on that pin, high voltages and low voltages, to turn our LED on and off. And then this completes our statement for pin mode for pin 13. You remember, you have to terminate each statement with a semicolon. So the next pin we have left to pin mode is LED cathode pin, and it is also an output. And an important note is, if you do not tell Arduino which pins you're going to use and how you're going to use them, later statements that will attempt to use these pins, even though they are executed later, they will not do anything. And I wish that Arduino would have an error that if you attempted to use a pin that you did not pin mode, that it would give you an error when you compiled or verified your sketch that you did not pin mode it first. So now that we have this setup function here completed with a couple statements, these are statements that are run once. We only need to tell, in normal situations, only need to tell Arduino once which pin we're going to use and how we're going to use it. Now, inside here, the next function we're going to talk about that's listed on the board I told you about is a function called digital write. Digital write will place voltages onto an output pin. A low value puts 0 volts onto the pin. A high value puts 5 volts onto the pin. So we want the cathode pin to be at ground all the time, or to be at 0 volts. So we don't want to have to keep doing this over and over again. So we're going to put a digital write for the cathode pin in the setup function, and we're going to, so it will only be executed once when the code is executed, or if you hit the reset button, or when it's downloaded for the first time. So we are going to do a digital write, and you notice that it changes color because it is a keyword and a known function. And a function has the braces, so we're going to have an open brace. And the digital write wants to know what pin you want to write to. We want to go to the LED anode pin, and we want to write a low to it. We want to put 0 volts onto that pin. So commenting this program, I would say apply 0 volts to LED anode pin. And that's done with the digital write. Now we are done with our setup, and we are done with declaring our variables. So there are 3 areas, remember, that we have to put our syntax, our code. And so there's the area above the setup function where we can put our header, and we can put variables. And we'll talk more about variables and functions later. This is an introduction so you can get up and going writing your programs and sketches. Now in the loop, what we want to do is we want to do the blink function again, except we're going to use an external LED that is connected to pins 13 and 12. Now 13 is going to be the anode, so the anode is the long lead of the LED, and the cathode goes in 12, which is the short lead, and that you will insert them into here. So once we have that hardware in place, and we've told Arduino with our pin mode that we're going to use those 2 pins as outputs, then when it's an output, as we talked briefly, Arduino is responsible for putting voltages on those pins. And it does this by using the digital write function. So in our loop, we are going to put statements to control the LED to turn it on and off. So the first thing we want to do is we want to turn on the LED by applying 5 volts to pin 13. Right? And we do this with the digital write, and the keywords and functions and in Arduino are case sensitive. So when you write digital write, everything is lowercase except for the W, which is capitalized. So if you do it right, it changes color. We're dealing with a function, so it starts with an opening brace, and it wants to know what pin to write to. So the box that we want to represent the pin number that we're going to use, the name of that box is LED anode pin, comma. The comma is a delimiter, and it tells the function that separates the 2 arguments that it's going to be using. So the values, or the items that the function needs, are called arguments, and this function requires 2 of them to work. The first argument wants to know what pin to write to, and the second one what value. It's a digital write, so it's either going to be low or high. We're going to do high so that we can put 5 volts on that pin. Now we need to wait for the digital write to apply 5 volts, and we wait in Arduino sketches using the delay function. The delay function uses 1 argument, and its units are in milliseconds. Now remember, 1,000 milliseconds equals 1 second. So let's apply 5 volts to the LED for 1 second. Which would be 1,000 milliseconds. We use the function delay, and this argument is 1,000, and it terminated with that. Now, after that time, we want to turn the LED off. We do that by using another digital write, and the pin is going to be analog pin, and this time we're going to be low. So remember, we want to comment everything. So we're going to be using the forward slashes. So we're going to say turn off LED. And so now it was on for 5 seconds, and now we're turning it off. Now when we turn it off, we also need to wait a small time, or wait for, let's say, 1 second for the LED to be off. We also need to give the LED time to be off as well. Remember, programs, when they're executed, they will execute every statement as fast as they can. If we do not use delay statements and functions to slow things down, we will not see, there will not be enough time for our commands to do what we want them to do. So we will delay for 1,000 milliseconds. We don't have to put ms in here. It knows that we put in there is milliseconds. So the loop function, it executes all of these statements. Now it ignores the comments, and so when the program runs, it's going to, from the beginning, it's going to ignore the comments. It's going to say, oh, we're creating a box in memory called of type integer, so the objects that are put in there are going to be integers, whole numbers. So we have this box named LED anode pin. We've given it the value 13 to be in there. And the nice thing also is, if we ever wanted to change these pins later, we only have to change them in one spot, and then everywhere else they will have that new value. So we've created 2 boxes, one called LED anode pin, LED cathode pin. And in the setup function, we've used pin mode functions. And I should also comment this one, telling Arduino we are using pin 12 as an output, because if we don't do this, it doesn't know how the pin should be used, and it's very important to use pin. If you use a pin, you have to pin mode it. So the order is not important half the time, but if it is, you just put it in the order that you want them to be created. After we have told Arduino that, we're doing a digital write one time only. One time only when this program is running. And so the LED anode pin is going to be have a 0 volts on its pin. Then we jump into the loop where we're going to turn the pin on by digital writing the LED anode pin high, and then waiting 1,000 milliseconds, so it's 1 second. Then we will turn it off, and then wait 1,000 seconds. Now, because it's a loop, what it does is it'll automatically, after this delay, it will jump right back to the digital write here, and execute this statement, putting 5 volts back on, and then it'll wait a second, then it'll put 0 volts on, and this is how the blink function works. So you should create a file, a new sketch called tut1 if it were. You do that. Once you have that, you have this save button here, and you're going to navigate to your C drive. Now my computer here is not Windows 10, but anyway, you're going to go to the Arduino folder with your period number and the name. Let's see here, and you're going to save it in on your hard drive. Alright, where am I going to put this? Fresno High, Arduino. Give it a name, and you call this one tut1, and save it. Now once it's saved, you can verify it and the progress board here, and if there are no errors, then your program is ready to be uploaded to the Arduino board. So you can see I have no errors. That just means that I have used the correct syntax and grammar that Arduino likes to see. The next step is to click the upload button, and it will download to or upload to the Arduino and start running. So with the Arduino connected to your computer using the USB cable and configured correctly, you will upload the program. It will start running, and this program will control these 2 pins. And what you need to do to see the results of that, you also, in addition to the Arduino board, need to place a diode of any color into pins 13 and 12. So go ahead and do this, and then I will do another tutorial showing how to control more than one. So 2, and then you can extend it to doing 3 for your traffic light. Okay, there we go.